Keno Hill. So here we're lucky enough to have two major types of veins, each one of which could be, host significant ore shoots. So that's the biggest difference. The other thing that's very ties the two of them together is that both areas seem to be intrusion related. The intrusions aren't right on the property, but they're nearby, and there seem to be a similar intrusion. So a lot of geologic similarities. I can tell you, if you took a type 1 vein specimen from the Plata property and dropped it somewhere in the ground of Keno Hill, no one would be able to tell you that it wasn't from Keno Hill. They are virtually identical. Type 2, on the other hand, as I said, is quite different than the type 1, and but both are potentially very important.
One thing to mention, Doug, about Plata is that the discoveries or prospects identified to date are constrained to topo highs. What is the potential for finding mineralization elsewhere at Plata?
Well, I think that it's, sorry to cut in, I think it's excellent. In the Keno Hill district, the original discoveries similarly were made near the tops of the hills where it was fairly easy to find float trains and then ultimately trace the float back to the source veins. When you got into the lower areas where there was either glacial till or a lot of talus cover, the veins in both camps tend to be recessive, as you'd expect. There's alteration around them, which makes them easier to erode. And the vegetation masks a lot of the mineralization. In Keno Hill, some of the most important deposits took literally from the time that the first float samples were discovered by prospectors, it would take as many as 10 or 15 years before they were able to find the actual source that the veins came from. So the work that's been done at Plata to date is really, it was identified very quickly. They found the mineralization along the top of the hills, proceeded almost immediately to high-grade mining. And there really hasn't been that much systematic exploration done down off the edge of the hills. One of the most important things that's happened in recent times and led to some really important new discoveries that were made in the Keno Hill district was the importance of structural mapping. There was a very, very thorough remapping of that district, and it led to some important observations, which in turn led to discovery of what's an incredible ore shoot at the Birmingham deposit that was missed by the old timers. There's never been anywhere near the type of systematic work done at Plata, and we just began to scratch the surface last year. So I think as we, broaden the areas of geochem coverage, do more systematic mapping and prospecting, and then follow it up with trenching and drilling, I think the potential here is for, many, many more discoveries.
Absolutely. Even from a geochem perspective, much of the property isn't covered yet. You could use more, recent and modern geochem or soil sampling. And then in terms of drilling, I mean, it's only a fraction of the drilling has been done at Plata you see at Keno Hill. I mean, I'm sure Keno Hill has probably got hundreds of thousands of meters of drilling by now, and we probably got a few thousand meters at Plata.
Yeah, millions of meters of drilling, probably hundreds of thousands of meters of underground development. Keno Hill has had over a century of exploration. And one of the things that was used there very extensively was just systematic rotary drilling at very close spacings along any vein that was the slightest bit perspective. So we're in very early days at Plata. And again, what a lot of people don't realize is at Keno is that the individual ore shoots are relatively modest. They only make up about 2% of the planes of favorable faults across the whole of the property. And even the richest veins in the Keno Hill district, it's about 15% of the plane of the vein it makes ore. So, to have some fortuitous exposures at Plata, we were able to find fairly quickly. It's going to take a lot of systematic drilling to follow it out. And again, that's the type 1 veins. The type 2 vein, I'm amazed at the continuity that has occurred with the drilling that's being done. And the vast majority of the work at Plata has focused on the type 2 veins, because it's more predictive. You're targeting the thrust faults, a little bit easier, higher density of mineralization. But both styles need a lot of work. Both are wide open to extension. So I'm very optimistic that if we continue to explore Platte, more discoveries will be made.
Yeah, that's one thing I noticed when we were looking at the 3D model the other day that Peter had prepared at Archer, is at the P4 zone, which has seen the most drilling to date, you can clearly see a continuous zone emerging. It's got probably 400 or 500 meters of down dip extension and probably 150 meters wide, and fairly consistently hitting the zone. That's just one sort of zone. And all along that Aho zone, which extends for at least some 800 meters along strike along the Platte thrust, very little work that's been done in terms of drilling. The rock chip sampling along there and the soils along there clearly suggest it's mineralized. A bit of drilling at the P3 zone has hit mineralization, and you can see, potential shoots emerging there. I mean, this zone is 800 meters, strike length right now, as far as we know. I would think that has huge potential just in terms of infill work and finding, potentially other shoots just along that 800 meter corridor.
Oh yeah, and the thrust faults that are hosting it extend the length of the property, so you're talking kilometers of strike length, and it already has demonstrated that it persists to considerable depth. Plus, it's only one of two major thrusts on the property. There's never been a hole into the second thrust. We have no idea what it might hold for us. And interestingly, when we drilled some of the holes at the P3, we let a few of them run a little bit deeper below the expected intercept of the type 1 veins, and we encountered type 1 intercepts underneath the type 2. So those high-grade structures that host the type 1, persist clearly underneath the thrust faults. So there's a little potential for a lot of blind discoveries down dip there as well. So, the potential here, it's going to take a systematic effort for a number of years, but the potential resource could be very, very large.
Absolutely. And I'm glad you mentioned that, the second thrust fault, the rogue thrust, is there. And then you have this package between the two thrust zones. And that's, that's a prospective sort of target area as well. You can get to these strike slip salt faults, I guess, between those two thrusts, and type 2 veins. Yeah, it's in that zone that have never been targeted before. It's sort of an interesting conceptual target area to look for in the future, I guess.
Yeah, the other thing that so we've talked about type 1 and type 2. There is a third type of mineralization on the property, which should be overlooked as well. Within the stratigraphy, there's periodically there's packages of limestone, and those carbonate rocks are quite reactive. When the fault structures cut them, the faults act as channelways, and the fluids have come up, and then locally we've seen pretty strong evidence of replacement within the carbonates. So that's a third style of mineralization, which is likely to have significant silver and lead with it, but is probably most attractive for zinc. So that shouldn't be overlooked as well. So again, it's going to be a combination of lithological and structural mapping to identify where those favorable areas will be below surface. But I think the potential here is for multiple styles of mineralization with at least three main commodities, four counting gold.